Hello everyone. So in this video, let's talk about another problem from Leetcode. The problem name is count good nodes in binary tree. Let's talk about the problem statement first. Given that you are given a binary tree, a node X in the tree is named good if in the path from root to X there are no nodes with value greater than X. Okay. So let's understand this line first and then we'll go to the actual understanding. So it is saying that a node X, X means like any node, is called good. So any node in this tree is called good if in the path from root to X. So let's assume I'm taking, or let's understand here. Let's assume, can I say this to be good? So any node is told to be good if in the path from root to X. So in the path from root to X, there are no nodes with a value greater than equal to X. So which means that in the path from this to the root node, there should be no value greater than 5. Then that node is called good node. You have to count out the number of good nodes in this binary tree. So for every node, you have to tell with that whether it is a good node or not, which means that for this node to be a good, for this node to be good, the path from this node to the root node, every value should be less than this value, which means that this has to be greater. This has to be uh, greater value. Okay, so this has to be the greatest value between the path from this node to the root node. Okay, so how can we check that first? So for this, I think so. What I thought when I solved this problem out was to have the maximum value when I reach this particular node. If I reach a particular node and because I'm doing some sort of a DFS traversal, let's assume if I just do the very simple traversal over this tree, that is the DFS. If I do a DFS traversal over this tree, then if I reach a node, I know that this is because I'm doing DFS, then that has to be the shortest path, and shortest path in the tree is the direct path. So because I'm traversaling over this tree using DFS, if I somehow know that what is the maximum value I've seen till now in that particular path, for that node has to be greater than the maximum value, because that node has greater than the maximum value, which means that the path I have taken from root till that node, I know the maximum value. If I know the maximum value, I can maximize and check that whether the node I am currently on should be greater than that value, because I have reached from the root node to that node. So if I've reached from the root node to that particular node, if I store or if I know somehow the maximum value when I reach that particular node, and if that node value is greater than the value which I've used to reach that particular node, then that has to be node. Let's take some small example to understand that as well. So let's take this only. So what we can do is I can make one more variable. Let's assume whatever you can name it. Let's assume name it maximum. Uh, so I will take whatever is the maximum I've seen till now when I am doing a DFS traversal over this tree. So what you can also see is that the first node has to be always a good node, because this is already a root node. So the path from this node to the root node is obviously this value only, and this has to be greater than equal to this particular value. So this has to be always good node. So no node with a value greater than x exists. So no value should be greater than x, which means that all the values should be less than or equal to x. So this node to the root node, every value should be less than or equal, because equal to 3 is always a good node. And what I'll then do is that I will do a recursive call towards right and left, and I will send what is the maximum I have seen till now. I have seen maximum till now 3. Now this value has to be larger than this value. Okay, because in this path, this is the maximum I have seen. But I want this to be the most maximum, because that's the problem. Then that has to be a good node. If this is the most maximum I've seen till now, this is not. So this will not be a safe node. This is obviously greater than 3. So this means this is a safe node. Now, because as you can see, the maximum I have seen till now in this path is 3. But because now I've encountered 4, so the maximum I will be sending down this path will be 4. So I have to send out the maximum I've seen till now with maximize it with the current node value I am on. So as you can see, I am on 4, so which means that now the maximum I have seen till now in this path is 4. So I will send 4 here. So obviously this value is greater than 4, so this is also a safe node. I will send 4 here. This is not greater than 4, so this will not be a safe node. This is 3, so this is 1. So the maximum I've seen till now in this path is 3, because as you can see, this is 1, so this will not be maximum. So 3 is sent and greater than equal to 3. So these all are the safe nodes. So I have to also send some sort of a count variable that can store what all are the count of nodes that I've seen, and I can just keep on incrementing count and just print out. Okay, that's a complete logic for this particular problem. I'll go through the code. If you have more doubts, you can put it down in the comment box. So what we have done here is that we have this good node function. We have to find out the good nodes in the left part and the right part, because the first node is always a good node. So as you can see, so this one that is added in the answer is the first node. So then I will recursively call this check function to check the number of good nodes in the left part and the right part. So I'll call the left half and the right part. I will send the maximum I have seen till now in this path. So in this path, I will send 3 in both the values, because the root is the maximum I've seen now. So whatever is the root I have, I will send this root value in the left part and the right part, because that is what the maximum I've seen till now. And because I want to find out the count of the maximum number of nodes in the left half and the right half that are good, so I will take these two variables to find out the maximum count, or the count of good nodes in the left half and the right half. So I will also set these variables, and that will store the count because I've taken it by reference. And in the end, the maximum number of good nodes, or the nodes actually, the good nodes in the complete tree is 1, because the root node and the left and right, which is stored in count 1 and count 2. Now what this check function is doing, this check function is just a simple DFS recursive function. So what we have done is that, so that every DFS or every like recursive function, we have a base condition and the actual recursive condition. So let's talk about recursive condition. The recursive is that whatever node I land upon the recursion, if its value is greater than equal to maximum, then obviously it is a safe node or a good node. So in that condition, I will increment the count variable. And then when I've checked this, I have to now go both on the left hand side and the right hand side. So I will go to the left hand side, right hand side. But as you can see, I have to now pass what is the maximum I have seen till now in this path. So this is the maximum I've seen above to this path, including the current node I am on. So I have to maximize this over the maximum I've seen this till now with the root node I am on. Okay, so I want to maximize this in both the left half and the right half, and then send the count as. And the base condition is that if I land upon a null pointer, then just return. Okay, this will keep on incrementing the total count of safe nodes or good nodes, you can say. And then in the end, we have turned good nodes in count 1 and count 2 for both of the left subtree and the right subtree. Okay, that is the complete logic and code part for this problem. The total time complexity of this problem is O of n, only because I'm traversing over this whole. Okay, because this is like traversing over the left half once, right half once. So that's the complete logic and code part for this particular problem. If you have any doubts, you can mention on in the comment box of this video. I will see you in the next one. Keep coding and bye.